Hello everyone. Today we are going to discuss about dimensions. We have already studied about the fundamental and the derived quantities. So what are fundamental quantities? The physical quantities which cannot be further simplified in the form of any other quantity, right? And derived quantities are the quantities which can be expressed in terms of the fundamental quantities. So the fundamental quantities, the examples are mass, length, time, right? And derived quantities are acceleration, velocity, etc., right? So here fundamental quantities, these cannot be simplified into other physical quantities. For example, mass, length, time, etc. Then we have derived quantities. Can be simplified, can be expressed in terms of fundamental. For example, velocity, acceleration, pressure, etc. Then we have a new concept of dimensions. What are dimensions? Dimensions are the powers to which the fundamental quantity can be raised in order to express a given derived physical quantity, right? So right. So for example, some dimensions are given to the fundamental quantities. This is mass, length, time, temperature, luminous intensity, current, electric current, and then amount of substance. These are the fundamental quantities. Its representation is, the dimension of mass is represented as this within the square bracket, and here this is L, here this is T, temperature is K, luminous intensity is candela, current is A, amount of substance is MOL, right? So how can we write the dimension for the derived quantities? Now let's take some examples of derived quantities, dimensions of derived quantities. So suppose velocity, we have to write velocity is what? Displacement upon time. So this is L upon T. So this is L T minus 1. If you want to express for mass, you can write m to the power 0 Lt minus 1. Similarly, acceleration is velocity upon time. So this is Lt minus 1 upon t. So this is Lt minus 2. And if you want to write with mass, so m will be 0. So this is acceleration. Similarly, we can write for pressure, force upon area. Force is mass into acceleration upon area. So mass into acceleration means m, and for acceleration also we can calculate. We have already calculated. Acceleration is Lt minus 1 minus 2. So this is m Lt minus 2 in the numerator. Area is L square. So this is m L minus 1 T minus 2. Similarly, we can write for momentum. This is mass into velocity. So this is m. Velocity is Lt minus 1. Right? So this is momentum. We can find for coefficient of viscosity 6 pi eta r v. So for eta dimensions, this is F upon 6 pi r v. So F is, all forces have same dimensions, right? So this is m Lt minus 2 upon 6 pi has no dimensions. This is L. This is Lt minus 1. So this is m. This will be cancelled. L minus 1 T minus 1. So this is the dimensions for coefficient of viscosity. Right? This is eta. Then we have we can have four types of quantities. One is dimensional constants, dimensional variable, then dimensionless constants, and then dimensionless variable. Now here dimensional constants means, for example, gravitational constant, we can calculate its dimensions. It has some units, that's why it has dimensions. So gravitational constant ho gaya, you have your universal gas constant, etc. Then we have dimensional variables. All these quantities are dimensional variables. So like velocity, acceleration, force, etc. Then we have dimensionless constants. These are pi, right? And then this is pi. E is exponential constant. So this is pi 3.14. It has no dimensions. These are constants. And then we have dimensionless variables, that is angle, right? Strain, relative density, because in all these angle is written as sine theta, tan theta, cos theta. So that angle is written as sine side upon side, so length upon length, so this will be cancelled. Strain change upon original, relative density is the comparison of the densities, so this will also cancel out. So these are the basic concepts of dimensions. I hope you understood it. That's all for now. Have a nice day.